Next, solving integral equations, right, using Fourier transformation. So, solution to find the solution for an integral equation using Fourier's transformation idea. It's an important topic. So we'll see the problems. Solve the integral equation integral 0 to infinity f of x cos px dx, which is equal to 1 minus p if p is lies between 0 and 1, 0 if p is greater than 1. Hence deduce that integral 0 to infinite sine square t by t square dt, which is equal to pi by 2. So given integral 0 to infinite f of x cos px dx is equal to 1 minus p if p lies between 0 and 1, 0 p is greater than 1. So to solve this integral equation means to find the solution to the integral equation, that is to find the value of capital F of x, right? That is the solution, right? So given equation is 1. Let integral 0 to infinite f of x cos px dx is equal to f of p, right? So this is equation 2. So f of p is equal to 1 minus p if p is lies between 0 and 1, 0 if p is greater than 1. That is equation number 3. So multiply both sides of 2, equation 2, by root of 2 divided by pi, 2 divided by pi, we will get, so multiplying root 2 divided by pi integral 0 to infinite f of x cos px dx, which is equal to root 2 divided by pi f of p. That is equation number 4. We know that Fourier cos transformation of f of x is capital F c bar of p, which is equal to, because here in the problem they are using capital F of x, right? That is why we are using capital F bar of cp, right? And also the integral equation involves cos px, that is why we are using Fourier cos transformation, right? That is equation number 5. That is it is equal to root of 2 divided by pi integral 0 to infinite f of x cos px dx. See fourth equation left hand side, root of 2 divided by pi integral 0 to infinite f of x cos px dx. Therefore f bar of cp, which is equal to c of p, which is equal to root of 2 divided by pi f of p. That is equation number 6. Now to find f of x, so we need f of x means we know inverse, we have to use inverse Fourier transformation, right? So we need to find capital F of x, so we have to use inverse Fourier cos transformation, right? So we know inversion cosine formula, cos formula is given by capital F of x is equal to root 2 divided by pi integral 0 to infinite f bar of c of p cos px dx, sorry, cos px dp. That is equation number 7. So now we are going to use 6 in 7. So f of x is equal to root of 2 divided by pi integral 0 to infinite from 6 fc bar of p, which is equal to root 2 divided by pi f of p, small f of p, right? We are using that root 2 divided by pi small f of p cos px dp. So root 2 divided by pi is a constant, take it outside from the integration. So root 2 divided by pi, root 2 divided by pi. So multiplying both, so you will get 2 divided by pi, right? Integral 0 to infinite f of p cos px dp, right? That is equal to, that implies f of x is equal to 2 divided by pi, right? So here there are two limits, because f of p is defined as one is 1 minus p in 0 to 1, and another one p is lies between 1 to infinite, the value of f of p equal to 0. So that is why we are splitting the integration, which is equal to 2 divided by pi integral 0 to 1 f of p cos px dp plus 2 divided by pi integral 1 to infinite f of p cos px dp. That is equation number 8. So from 3 and 8 we are going to use the value of f of p from 3. So in 0 to 1 f of p value is 1 minus p. So f of capital F of x is equal to 2 divided by pi integral 0 to 1 minus p cos px dp plus 2 divided by pi integral 1 to infinite f of p value is 0. So 0 into cos px dp. So that is equal to 2 divided by pi integral 0 to 1 minus p cos px dp. So we are going to evaluate the integral using Bernoulli's formula and or integration by parts, both, right? The extension of integration by parts is the Bernoulli's formula, right? So integral u dv, which is equal to uv minus u dash v1 plus u double dash v2 plus etc minus plus etc, right? So here u dash u double dash are successive differentiation of u, and v1 v2 etc are successive integration of dv, right? So here u is equal to 1 minus p. So here differentiation is with respect to p, right? And dv is equal to cos px dp. Therefore u dash, that is equal to du, which is equal to derivative of 1 minus p with respect to p, that is minus 1, and v is equal to integral dv, which is equal to integral cos px dp, which is equal to sin px by x, and v1, which is equal to integral v dp, which is equal to integral sin px by x dp. So 1 by x is constant with respect to this integration, because this integration is with respect to p. Integral sin px dp is equal to 1 by x, so for sin px integration minus cos px by x. So that is equal to minus cos px by x square. So using this idea to evaluate that integral, so capital F of x is equal to 2 divided by pi integral 0 to 1 minus p cos px dp, which is equal to first uv. So 2 divided by pi is common, so u is 1 minus p and v is sin px by x, limit is 0 to 1, minus integral v du, right, minus 2 divided by pi. So du, that is derivative of u is minus 1 into v is, that is v1. So we are using Bernoulli, right, v1. So v1 is minus cos px by x square, right? So limit is 0 to 1. So applying upper and lower limit 2 divided by pi. So instead of p, put upper limit 1 minus 1 sin 1 into x by x, minus instead of p, put lower limit 1 minus 0 sin 0 by x. In both cases 1 minus 1 0, so that also 0, then sin 0 0. So in both cases the value of the integral is 0. First integral is now minus 2 divided by pi cos upper limit, right? So upper limit is cos 1 into x by x square minus cos 0 lower limit by x square. So that is equal to minus 2 divided by pi cos x by x square minus 1 by x square. So therefore capital F of x is equal to 2 divided by pi. Taking x square is common, take it outside. So multiplying with minus, you will get 1 minus cos x. That is equation number 9. Hence the solution of the given integral equation is f of x is equal to 2 divided by pi x square 1 minus cos x. Now we are going to deduction. So from 1 and 9, right, equation number 1 and 9, integral 0 to infinite f of x cos px is equal to 1 minus p, p lies between 0 and 1, 0 p is greater than 1. This is first equation, equation number 1. So integral 0 to infinite f of x value is 2 divided by pi x square into 1 minus cos x cos px dx, which is equal to 1 minus p, p is lies between 0 and 1, 0 p is greater than 1. That is 2 divided by pi integral 0 to infinite 1 minus cos x by x square cos px dx, which is equal to 1 minus p if p is lies between 0 and 1 and 0 p is greater than 1. Taking a limit p tends to 0 on both sides, we will get limit p tends to 0, 2 divided by pi integral 0 to infinite cos x by x square cos px dx, which is equal to limit p tends to 0 1 minus p, p is lies between 0 and 1, 0 p is greater than 1. So 2 divided by pi. So applying the limit 1 integral 0 to infinite 1 minus cos x by x square. So cos 0 into dx, because p tends to 0, which is equal to, here p tends to 0 means we will get 1 only, right? 1 minus p, first term only, right? 1 minus 0, that is 1, right? So 2 divided by pi integral 0 to infinite 1 minus cos x by x square, because cos 0 1 into dx is equal to 1. Therefore integral 0 to infinite 1 minus cos x by x square dx is equal to, so taking that 2 divided by pi on the left hand side to the right hand side, pi by 2. We know 1 minus cos x is equal to 2 sine square x by 2, trigonometric formula. Using this idea, so integral 0 to infinite 2 sine square x by 2 by x square dx is equal to pi by 2. That is equation number 10. So put x by 2 is equal to t. So dx by dt is dx by 2 is equal to dt. Dx is equal to 2 dt. There is no change in the limit. When x is equal to 0, t is equal to 0. X is equal to infinite, t is equal to infinite. So 10 implies integral 0 to infinite 2 sine square t divided by, put x is equal to 2t, right? Because x by 2 is equal to t, therefore x is equal to 2t. 2t square. Instead of dx, put 2 into dt, which is equal to pi by 2. So 2 sine square t by 4 t square dt, which is equal to pi by 2. There, this implies sine square t by t square dt, which is equal to pi by 2, right? Thanks.